Today I'm going to talk about Riak.js, and unfortunately you can't see the picture, but this is a picture of a bunch of turtles sitting on top of each other. And I've tried to use the subtitle JavaScript turtles all the way down, and I hope you'll see what I mean as we go forward. So we're experiencing this progression of JavaScript adoption in lots of places you wouldn't expect it. So this is a typical web stack. You know, you've got the browser layer, you've got the server layer, you've got a database layer. And the typical stack kind of looks like this, or at least the traditional one does. You've got JavaScript in your browser that powers your UI, you know, shows your countdown, whatever. And you've got some kind of server-side language like Java, Ruby, PHP, Python, the list goes on. And then inside your database you have SQL. Well, so now we have Node.js, right? So we can build great server applications in JavaScript, which is totally awesome. But you notice that that little section there, the DB, hasn't changed yet. So what can we do to bring JavaScript to the database? So like all these turtles that are marching toward the sea, and I hope you can see that, we're on a path, and that path is adoption of JavaScript in all places. All right. So you're probably saying, what about CouchDB? CouchDB has JavaScript. And CouchDB is great. I like CouchDB a lot. And I'm going to apologize in advance for this straw man argument. So no offense to any of the CouchDB guys that are in the room. It has been my experience, even long before I started at Basho, that the types of applications people want to build with CouchDB are not the types of applications that people would want to have, not the same types of applications that you would write for Node.js. And so, in a sense, you don't want to end up like this turtle. And if you can't see it, there's a car on the road way behind him. You know, you want to rather be like these turtles, right? You want to be Node.js ninjas. So I'm going to tell you a bit about Riak and why you should use Frank's awesome Riak.js driver. So say hi to Frank later. So what is Riak? Riak is a distributed, fault-tolerant, replicated data store. So if you think of like, a lot of people are familiar with CouchDB, a lot of people are familiar with Redis in the room, I'm assuming. It's a key value store. But the big difference is that all of your data is replicated among a bunch of machines. So we like to say your data is safe with us. You can lose a machine, your data is still available. The next thing is that it scales out linearly. So you know, a lot of people say lots of things about scalability. And what we say is just add more machines. So this is not that every machine has all your data, but every machine can serve any request for any client. And Riak also has a flexible data model, which means it's essentially key value, but you have a couple extras, which I'll talk about in the course of this talk. And you have MapReduce, and we also have pretty recently released Riak Search. Now, of course, with a flexible data model, great power comes great responsibility. So in your app, you're going to have to take a little bit more ownership of how you structure and manipulate your data. Now, I've glossed over a lot of the high-level features of Riak, but Matthias, who's also taken some awesome pictures today, made this awesome animated GIF. And I think it explains better than what I could do in words how Riak works. So in this little animated GIF, you've got 8 nodes in your cluster. You send a request to one, it goes out to 3. And then if you lose one, the data goes to some other node that might have a copy or store a copy. When that other node, the node that was lost comes back, the data goes back where it belongs. Oh yeah, and it has JavaScript. So let's talk about Riak.js. I pointed out Frank earlier. Riak.js also has this beautiful website, which has some pretty awesome documentation on it, how to get started. But let's talk a little bit more in detail about that. So to get started with Riak.js, you want to download Riak or Riak Search. Downloads.basho.com has all the binary packages, and also if you want to bother building it yourself, there's a source package available. And then you'll npm install Riak.js, and I like the latest because you know, the production releases are kind of erratic, but the latest stuff is always awesome. Works with Node 0.4. Or you can clone it beyond the bleeding edge. So let's see what else I got in here. OK, so let's look at the basic client operations. Isn't that a cute little turtle? OK, so the operations for the client are really simple. You require Riak.js, and you call getClient on the module that's exported. And that gives you your basic client like you would expect with any other Node library. And then, so if you want to fetch an object out of Riak, you give it a bucket and key. All of your keys in Riak are namespaced within a bucket. You don't have to create them ahead of time, but they provide a nice way to organize your data. And just like most Node drivers, you send it a callback. So your data actually doesn't return from that function call. It's passed to the callback. And the callback, like you're used to, has the very first argument is going to be an error object, if there was one. And the next one is going to be the actual data you got back from Riak. So in this case, we're logging to the console that we found that object. If you want to store an object, you do a very similar thing. And you can pass it JSON to store the object. It'll automatically marshal that and ship it off to Riak. And when you request it back, it will also come back in JSON. So just fair warning, from now on, I've elided the callback because it just kind of adds some extra noise. But you'll want to be using that callback to get information about your request. OK, so obviously you can fetch objects, you can store them, you can also remove them. You can check if they exist, and it looks like my flipping's messed up. This is a cool new feature that Frank just pushed out yesterday, right? Yeah. So Riak has the ability to stream lists of keys that you have stored. So you can pass it this keys stream if you want to find out what keys are in the framework bucket. And then it returns an event emitter. So you can listen for the keys event on that and then start the request. Yeah. Event emitters are awesome. Use them. So you can get all of the objects from that bucket if you want. And I'm sorry, I use object loosely. It's kind of a terminology we have inside Basho, but it basically means the key that you've stored plus all the metadata around it. So if that gets confusing, I'm not talking about JavaScript objects. You can also count the keys if you want to find out how many keys are in the bucket. So that's the basic, really simple. Key value, a couple extra things. But there's an interesting thing about the Riak.js driver, which is a meta object. And we've got a stack of turtles there on the right side. Sorry if you can't see it. So if you want to modify things about the request to Riak, if you want to find out some more information about what the response was, you have this meta object. And it always comes as the penultimate, or the ultimate in the case of the callback, argument to your function. So let's look at what you can do on requests. So with the meta object on requests, you're sending request time metadata. And these are important things like your content type. Now, unlike CouchDB or Redis, Riak doesn't care what you store in it. It doesn't have any idea of what it is. So it's the responsibility of the application to tell what kind of content you're storing. And that basically corresponds to the HTTP header content type. Now, Riak.js also does some things nicely for you, short circuits that if you're just passing a JSON object. You can also pass the client ID. This is important if you have an application like many Node applications will be that have heavy write load. The client ID helps us disambiguate concurrent writes in Riak. There's also links in user meta, which are some sort of useful metadata that we'll look at later. And of course, Riak is a Dynamo-like system. I'm sorry, this is not like really database crowd, so I'm kind of at a loss here on this. But you can tell it how many nodes you want to return a successful response when you submit a write or a read. And once those are satisfied, then it will return a response to the client. So you can tell it how much consistency you want, which is pretty awesome. And then return body just basically lets you, on a write, get back the resulting value that was sent to the server. OK, so let's look at what the meta does in callbacks. So again, response time metadata. This will include information like the bucket and the key that were stored. So you can choose to store something without a key, and Riak will pick a key for you. In that case, you want to read that key in your callback. And also the vector clock, which is just a crazy distributed systems thing that helps us keep track of who wrote what when. And that's all you really need to know about it. Just make sure that you pass it along. Again, the links in the user meta will come back. So if you've fetched this object from Riak, you'll get information about what other objects it's linked to and any specific application metadata. And then typical, HTTP-like things like the last modified date, the e-tag, the status code from the request. So under the covers, Riak.js uses the Node HTTP library to do most of its communication. OK, so if we want to take advantage of this meta, we might do something like, in this case, when we're fetching the object, we'll get it back in the data in the callback here. And then we'll add a link to that object and store it back. So in this case, we've taken that meta that came from the response. We call a special function on it, add link, that makes the Node.js object point to the VM v8. And then we're storing that back in Riak. Or you might do something like set the content type when you're saving for the first time. Excuse me. I said before that Riak.js will do a lot of things for you to make it really short, the kind of developer-friendly API that you're looking for. In this case, what it says is you only have to tell it HTML. It knows you're talking about text HTML. So that's great and all. We have key value access. You can store. But you definitely want to go beyond querying just key value. And I'm sorry, this turtle doesn't have any relevance to the slide, but I thought it was pretty cool eating a strawberry. So I mentioned links before. Links are a lightweight way to relate objects to one another inside Riak. And you can follow those links automatically. And so here's a turtle with two heads that are linked together. So if I wanted to find all of my friends, and this is the typical social network example, I would start at the object that is in the bucket people, the key Sean, and then I send it this specification, which is how to match links that are on that object. In this case, I don't care, the very first argument is the bucket. I don't care what bucket it's in, but I want to follow the tag that's friends. And that'll return a bunch of objects to your Node.js application that are all of those things that are linked from people Sean. And then there's people Matthias. In this case, we're going to follow his friends, but we're also going to follow anybody who are linked from his friends. So you can do this sort of fan-out type of query where if things are linked up right, you can get lots of interesting information about how things are related. And this has been a core feature of Riak for a long time. But wait a minute. You said that Riak had JavaScript in it, right? I did, right? OK. So I'm going to explain how JavaScript is down inside Riak as well. And that's with MapReduce. We do a lot of stuff with MapReduce when we're developing apps for Riak. And this is basically how it works. It's a little bit different than what you might have seen in Couch. If any of you use Hadoop, anybody use Hadoop? Yeah, just a few people. It's very different from how you use Hadoop, too. So basically, the idea of MapReduce is a functional idea. You start with a list of keys. Riak will fetch those keys and run a map function across all of them. And that's distributed around the cluster. So the map function runs where the data is stored in your Riak cluster, which makes it really efficient to load that from disk, et cetera. And then once all those map functions have run, and they can return any number of results from 0 to however many. They can be sent to a reduce function, which will coalesce a single value or a list of values and return that to the client. OK, that's great. Where's the JavaScript, you're saying? Well, the job, the list of keys, and all of the functions that you want to compute are submitted as JSON, which is pretty cool. All of those map functions can be JavaScript. That reduce function can be JavaScript. And then when it's returned to you, it's in JSON. OK, we got JavaScript. So let's look at how you run it. So in this case, I'm executing a MapReduce query. And all you have to do is on that client object that you initialized at the beginning is add the frameworks bucket. So this basically says, give me all the keys in the bucket and perform this job across them. And we're going to use a built-in function to map across all of those, which is called MapValues.json. And then when you call run, that actually sends a query as a JSON object over to Riak, and it'll execute it and return some results. So in this case, of course, we're just logging to the console the data we get back. A little bit more complicated example, and I think this is actually the standout feature of what makes Riak.js really tightly integrated with Riak. And that's that you can define a function inside your Node.js application, and it'll be turned into a string and sent over to Riak and executed over there. So if you don't want to break out of JavaScript and start writing strings for all your functions or calling built-ins, you can just write them in line with your code. It's pretty awesome. So in this case, I'll just describe what this MapReduce query is doing. We're going to start with a specific key, just the Node.js key inside the frameworks bucket. And then we're going to follow links on that to VMs. And remember earlier in my examples, I linked to the V8 VM, so we should get that object coming out. And on all those things that it's linked to, they're in that VM bucket, we're going to just parse the contents of that object as JSON and return the name property from the object that was parsed. And then in the reduce function, we're just going to sort the list of results and return those to the client. And I know this is like, Matthias wrote a couple blog posts a while back about why MapReduce is hard and why MapReduce is easy. And I'm sorry, I have to gloss over this right now, but those are pretty awesome ways to learn how to understand this programming model. OK, just one more example. In this case, we're using a new feature of Riak 0.14, which is called key filters. And what we try to encourage people to do with Riak is to use keys that are meaningful to your application. They may have some embedded information about the object that's being stored in them. And in that case, that makes it actually a lot easier to query them, because you can even say, I know exactly what the key is going to be. That's the ideal case. Or you can say, I know the key is going to contain this. And so key filters let you take a whole bucket listing, all the keys you've stored in that bucket, and filter them with various predicates. In this case, I'm taking all the emails in the email bucket and saying, these are the ones that ends with basho.com. Return only those. Now, the difference between that and just running a map function that might have an if-else in it is that you're not actually loading that data off of disk. So it's much faster. In this case, we're also using another built-in called map by fields. And this is a kind of a cool feature in that you can create generic map and reduce functions in JavaScript that take a trailing argument. And so you can parameterize those generic functions to perform specific tasks. In this case, I'm saying, OK, they need to be joined on 2010, January 1st. OK, and we run that. So there's also search. I mentioned that at the beginning. Riak Search is a full-text search engine, very similar, at least from the outside, to Solr. But on the inside, it's totally different, and it uses all the distributed stuff that Riak does. But Riak.js has special support for it. So if you want to have all your JSON documents that you're storing automatically indexed in Riak Search, you can just say db.enable index and then the bucket name. And that'll put on a pre-commit hook to the storage operations to index that in Riak Search. You can also just perform a flat search like you would expect with Solr. You send it a Lucene style query string. Say, give me all the documents that have the title scalable in them. And you can use search to feed a MapReduce query. So if you know a full text query that will satisfy the set of keys you want to fetch, then you can use that to feed a MapReduce query and just add your map and reduce functions on there in whatever combinations you need. OK, so there's some other things. That's the main features of Riak.js. There's some other things that are included. There's a Connect session store. In fact, that just got a pull request applied to it today, which is pretty cool. There's a miniature Riak. So we want to write tests for our applications, right? But sometimes those tests need to hit the data store. In this case, it's actually pretty awesome. What it does is it fires up a Riak that's a sub-process of your node test process and tells it to delete all the data in it at the end of each run. So you'll definitely want to look into that. Also, there's multiple ways to talk to Riak. The default is HTTP, but there's also a binary protocol which is based on Google protocol buffers, and Riak.js has some experimental support for that. And there's also a LUOC, which is, I'm sorry, kind of a weird name, but if you wanted to store large files in your Riak cluster, LUOC will split them up into chunks for you, and Node.js via Riak.js has support for that. So no presentation would be good without a demo. So this application is available on GitHub. I'm going to talk through a little bit of it. And it's also hosted on Joyent's node service. And so you'll be able to see that. OK, so what Reactant is a very simple Syslog server. So it receives UDP Syslog messages, it stores them in React Search, and then it serves them up in a nice little web interface, which is also powered by Node. And then you can search through all of your logs. So miniature logly type of thing. Interesting thing that we discovered when we were writing this, and this should come as no surprise to any of you, but don't block the reactor, OK? We actually found that we were dropping a bunch of UDP messages because we weren't deferring our writes to Riak. That was kind of interesting. So instead what we did is we set up a queue, we push messages into the queue, and then periodically check to see if it's over a certain threshold and then drain them, which actually worked really well, and we didn't really lose any messages. So we parse the message, we create a hash of it to use for the key, and then we push it into the queue. OK, let's see, go down here. So this callback, this process next queue message, is what actually pushes it into Riak. And we do use the typical tail call type of callback to pop something off the queue and then stick it into Riak. OK, and that's the rest of that's boilerplate. And then there's the web server, which we actually use the Riak.js session store with Express to have a simple login. And that's set up right here, this Express create server stuff. So we've required Riak.js up here. We've required the session store, which actually those fixes that we did in this project have been moved into Riak.js now, so you shouldn't have to see that anymore. And so we created a session store, stores its stuff in Syslog web sessions bucket, and uses the same client that we use for the web app. OK, and then there's some stuff related to MapReduce and filtering those queries. And I don't want to spend too much time doing a code review, because I know how boring that is. So we're going to look at the application. This is pretty simple, demonstrating using the session store. And if you go here, it's OK if you go here. I'm sure it'll hold up. It's basho.no.de. And the username is Riak, and the password is awesome sauce. OK, so now we've got pretty blank screen. But if we type, so we actually fabricated some Syslog messages to feed into Riak Search. And so some of them have this connection closed message. So if we click that in search, and we get back a bunch of text messages on the side that are, Syslog format you may be familiar with. And all of these, things had their connection closed unexpectedly. So you can make it filter that. So let's say we wanted, and those are all happening at the same time. The time's not going to be useful. So in addition to just searching, typical Lucene type of search, You could actually feed that to MapReduce like I mentioned before. And then we made a selector down here. You can select which map function you want. So if we just want the host names out of all those results, click search again. And my apologies for the interface here. It's kind of brutal. But here's all these results. So every one of these things that was a search result got passed through this map function that just returns the host name and a count for that. Now that doesn't seem very useful until you look at the reduce function and you say, well, let's group by values. And when you do that, you can see, well, web2.basher.com, yeah, that's probably a bit tiny. Web2.basher.com had 87 of these messages, and app1, and so on. So in contrast to the way that Hadoop does MapReduce and the way that CouchDB does MapReduce, you can build these things on the fly. You're not building views. You're not stuck into a fixed job. You can submit them whenever you want. And then you might also want to do something like, let's see, let's fetch the date and hour. And these all happen in 19 o'clock. 383 messages. So that's a little demo. And let's flip back here. I'd be happy to take questions. That's how to contact me. Check out the jsconf.basher.com site. Yes? How hard is it to replicate the server, the Riak server? It's built in. So you start with one node and you have 3 copies of everything. When you go to 3 nodes, there's a copy on every machine. You go to more and it's spread out even more thinly. So replication is automatic. Did that answer your question? Yeah, OK. Way in the back. Yeah, the question was, why would you want to use key streaming? And an interesting thing about the way streaming keys, or I'm sorry, key listing works in Riak is that when you submit a request for a list of keys, it goes out to 1/3 of all of the nodes in the system and says, give me your key list for this bucket. And so as you can imagine, with a big bucket, that's going to take a long time to smash into a JSON array and send back to the client. And that's going to take up a lot of memory if you've got a lot of keys. So key streaming sidesteps that and actually starts sending back results as soon as they get there. So this is actually a nice fit with the way that Node does things, and that you can receive events asynchronously.
Sean, thank you very much.
Thank you.
Sean's going to be around.